Hi there. Today I would like to present you a tool that I had developed a long time ago for testing distance relay, directional overcurrent relays, fault location. It's something that I had done manually, and then I did it on Excel and decided to do on a web platform so that you can access this tool through your laptop, tablet, or even your smartphone. So when I was in the States, I used to make use of test sets from Omicron or Doble. I'm not affiliate to any of these. I'm just telling you that these were the one that I used to use. And on the left-hand side, you can see the Omicron, the CMC 156, which I use quite extensively, the CMC 256 to some extent. And then on the right-hand side, you've got the Doble, the F series, the 2500, if my recollection. That was a single phase unit. So when you have limited output, you could make use of this tool to calculate quickly the voltage and the current that you'd need to inject to test. So here you've got some default values. You can see that you've got a source impedance here on the left-hand side. You've got the source with the voltage at 100 volts. Here in red, you've got the V test and I test. These are the values that you would inject onto the relay. Then you've got the ZL here with the positive and the zero sequence value. And then RF, which is the resistive value of the fault. And then on the bottom here, you can see that these are the impedance. So if you could measure it, that impedance would be equal to the difference of the zero sequence impedance minus the positive sequence divided by 3. Okay, so here it's equal to 0 because I've got the zero and positive sequence being equal, so the difference is equal to 0. So here you've got the 100 volts for the source. You can see that ZL and Z source are equal because what I have is the fault located at 50% of the line. So 0.1 plus J1 for the source, and then 50% of ZL, which is 0.1 plus J1 ohms for the line to the fault. Okay, so this actually, if you make a quick calculation, this is a potential divider. So the voltage at the relay location is basically half the value of the source voltage. So here you can see that it shows it's 50 volts here at the bottom. So, and then the current would be 49.8 with an angle of 84 lagging. So let's say that you want to change the value to correspond to the value that you have on your relay. So you can use these to make the changes, and you will see that these values would be calculated automatically. Okay, so you can do it manually, so you can use your keyboard. So I'll put it to 1. Okay, so here you've got as well the RF that you can change as well. So that would, if the RF increases, obviously the current would decrease, as you can see, and the voltage as well would increase. So let's put that back to 0. On the other hand, if you increase the Zn, which corresponds to the impedance to the ground for the generator here, conversely, the current still decreases, but the voltage at the relay location would actually decrease. So I think you can make use of this to quickly inject and see how the relay behaves and see the accuracy of your fault location within the numerical relay. One thing that I'm thinking to add to this tool is probably add another source and see how the infeed from a remote source would influence the distance calculated the relay location. That would enable you to test how the underreach or overreach would affect the relay, and whether the tripping and even things like the permissive underreach or overreach would be tested in this way. So let me know what you think. So if you've got any suggestions or comments, let me know in the comments, and I'll talk to you later. Bye.